Hello, welcome back. In this segment, I wanted to continue our discussion on finding the second maximum among three numbers. In the previous demos we did, we constructed second max using the program we wrote using program synthesis. Okay, we were able to synthesize a program that gives us the second max among the three numbers x, y, z. This was the logic we discussed. Okay, but you can see here we make calls to min and max 1, 2, 3, 4 times. That means there are 4 comparisons we are making use of to decide which is the second maximum. So I asked this question, can we optimize it further? Suppose we are allowed to use if then else statements. Can we do better than 4 comparisons? It turned out the answer is yes, and we can synthesize that. So let me show you the max without optimal max. I believe it's optimal that with 3 comparisons you can find out the second max. Let me show you the program now. Okay, so what I did is actually kept the examples as it is from the previous demo. All of these are different examples of what do we mean by second max without defining formally. I'm just training the computer, so to speak, with different potential or input-output pairs, kind of covering the space of the program, if you will. And then specifying the grammar. In this case, we are saying to the synthesizer, you're allowed to use if then else statement. That's the meaning of ITE. Okay. And we are saying you are allowed to use less than. Less than is the comparison between 2 inputs. Okay, start is an int type, and we are allowed to only compare integers and use x if then else statement in this case. Okay, let's synthesize a program now using this max 2 with an if statement. Okay, right away you get a output. This is the synthesized program. Okay, and it's a little bit difficult to read because it's in the raw SMT output, but we can easily structure this as a sequence of if then else statement, and I will show you the output after I did that. Okay, so here is the output. I'm going to write it in a text file, max 2 with if else, right, dot txt, and paste it for you here. Okay, so this line is what we synthesized from the program synthesizer, and we can rewrite this as follows. So it says if then else, right? If x is less than y, this is this part, and then the next saying x is less than z, and if y is less than z, then we know y is the second max. Otherwise, z is the second max. Okay, else it's x. So this part corresponds to this part. Okay, and then this else part corresponds to this else if then else part. Okay, so to make the long story short, how many comparisons do we need to decide the second max? The answer is 3. I don't know whether you can do it better than 3, but I don't believe so, because the synthesizer usually gives us the optimized solution. Okay, we are only allowing the computer to use if statement, no arithmetic operations. That's another important point. That's part of the grammar specification. Okay, so you can see here 1, 2, 3, at most 3 if comparisons or if statements are needed to decide the second max. Okay, of course, for every branch you have to consider that, but in any case there are only 3 comparisons at most. If x is less than y, we go into this branch, which needs at most another 2 more comparisons. If x is greater than or equal to y, then we have this part, which is also 3 comparisons in total. Okay, so this is very nice. We have an optimized solution to find the second max, and the synthesizer was very quick, as you have seen. In less than a second or so, we get the answer. Okay, all I'm saying to the synthesizer is that make use of the if then else statement. Okay, and compare the integers. That's the only thing we said. And of course, we give instead of a formal specification here, we give bunch of examples which we believe are good representation of the state space of the program. Okay. All right. That's basically it. Thank you very much.